The first deep-sea explorers. The role of the Challenger expedition. The Challenger expedition, which took place from 1872 to 1876, was the first scientific expedition to systematically explore the deep ocean. The expedition was led by Sir Charles Wyville Thomson, a Scottish naturalist and oceanographer, and it had a profound impact on our understanding of the deep sea. Goals of the Challenger expedition. The primary goal of the Challenger expedition was to survey the ocean floor and collect specimens of deep-sea organisms. The expedition also aimed to investigate the geology, chemistry, and physics of the deep ocean, and to develop new methods and instruments for studying it. Discoveries of the Challenger expedition. Over the course of its 4-year voyage, the Challenger expedition made a number of groundbreaking discoveries. It found evidence of the Mid-Atlantic Ridge, a massive underwater mountain range, and identified the existence of deep-sea trenches, where the seafloor plunges to depths of over 6,000 meters. The expedition also collected thousands of specimens of deep-sea organisms, many of which were previously unknown to science. Impact of the Challenger expedition. The Challenger expedition had a profound impact on our understanding of the deep sea and its inhabitants. The data collected during the expedition was used to create the first comprehensive maps of the ocean floor, and many of the specimens collected became the basis for new branches of marine biology. The expedition also spurred the development of new technologies and techniques for studying the deep sea, including deep-sea dredging and the use of submersibles and remotely operated vehicles. Legacy of the Challenger expedition. The Challenger expedition is considered a landmark event in the history of oceanography, and its legacy can still be felt today. Many of the concepts and techniques developed during the expedition are still in use, and the data and specimens collected continue to be studied and analyzed by scientists around the world. The Challenger expedition also paved the way for future deep-sea explorations and inspired generations of scientists and researchers to study the mysteries of the deep. The innovations of William Beebe and Otis Barton. In the early 1930s, William Beebe and Otis Barton developed new technologies that allowed them to descend to previously unreachable depths of the ocean. Their innovative devices and techniques were groundbreaking and opened up a new era of deep-sea exploration. William Beebe and the bathysphere. William Beebe was a renowned naturalist and explorer who had long been fascinated by the ocean's depths. In 1930, he and Otis Barton developed the bathysphere, a spherical steel diving chamber that could withstand the crushing pressures of the deep ocean. Beebe and Barton made a series of record-breaking dives in the bathysphere, reaching depths of over 900 meters. Otis Barton and the deep diving apparatus. Otis Barton was an engineer and inventor who collaborated with William Beebe on the bathysphere project. In 1934, he developed the deep diving apparatus, a more streamlined device that allowed for greater maneuverability and faster descent. With the deep diving apparatus, Beebe and Barton were able to reach depths of over 1,400 meters. Innovations and discoveries. The bathysphere and the deep diving apparatus were groundbreaking innovations that allowed scientists to explore and study previously inaccessible parts of the ocean. With these devices, Beebe and Barton were able to make a few important discoveries, including the existence of bioluminescent organisms and previously unknown species of fish and other deep-sea creatures. Impact and legacy. The innovations of William Beebe and Otis Barton had a profound impact on the field of deep-sea exploration. Their devices and techniques paved the way for future advancements in technology and helped to establish the study of the deep sea as a legitimate scientific field. Today, their legacy can still be felt in the design and use of modern submersibles and other deep-sea exploration tools. Life in the abyss. Overview of the unique adaptations of abyssal creatures. The abyssal zone is one of the most extreme environments on Earth, and the creatures that live there have evolved a few unique adaptations that allow them to survive and thrive in this challenging habitat. Extreme pressure. Abyssal creatures are adapted to survive the extreme pressures of the deep ocean, which can reach over 8,000 pounds per square inch. Some have thick, gelatinous bodies that can withstand the pressure, while others have rigid exoskeletons or skeletons made of specialized materials like chitin. Cold and darkness. The abyssal zone is also characterized by cold temperatures and complete darkness. Many abyssal creatures have adapted to these conditions by developing specialized sensory organs, such as large eyes or bioluminescent structures, that allow them to navigate and communicate in the dark. Unique diets. The food sources available in the abyssal zone are often very different from those in shallower waters. Some abyssal creatures are filter feeders that subsist on tiny particles suspended in the water, while others are carnivorous predators that hunt the other animals that live in the abyss. Adaptations for reproduction. Reproduction in the abyssal zone is often a challenge due to the harsh conditions. Some abyssal creatures have developed unique reproductive strategies, such as producing large numbers of eggs or using bioluminescent displays to attract mates. 5. Examples of adaptations. There are countless examples of unique adaptations among abyssal creatures. Some of the most fascinating include the fangtooth fish, which has the largest teeth of any fish relative to its body size, and the giant squid, which has the largest eyes of any animal on Earth. 6. Importance of abyssal creatures. Although the abyssal zone is remote and difficult to access, the creatures that live there play important roles in the ocean ecosystem. They are often keystone species that support the food web and provide essential ecosystem services, such as carbon sequestration. Understanding their adaptations and behavior is crucial for understanding the health and functioning of the entire ocean.